All right, welcome, ladies and gentlemen, for another live stream. And I do apologize. I'm not really sure. I keep on trying to set this up with YouTube's making a lot of changes. So I keep on trying to make these changes up here. And then I'm just trying to see if it follows along. And I'm not really sure what's going on, but I cannot get the new YouTube live stream to be working for me for my channel. So I just went live, and therefore I'm going to try to see if I can get connected with you guys on the chat. But it might be something I might have to come back to. Let me see if this is actually maybe works a little bit more over here. I'll try it one more time. But I've been gone for a week, not really gone for a week, but I was sick last week. So I do apologize if those of you were hoping for some questions. I just could not make myself go live. We were out of town, and it was just a lot. And then I was sick, and I was just like, I cannot push it. And I just didn't make any announcements from there. But I want to let you guys know that I am here for a chat, and we do have 5 questions that I brought in. The first couple questions actually came from the Facebook, because I really do want to make sure people are. It's a lot easier for me to ask questions on the Facebook. You know, some people did respond to me on, on the community chat in YouTube, which is fine. But until YouTube really has something that I feel is going to be beneficial for us to kind of have that conversation as far as questions and lead me to make sure I understand what you're looking for, I'm just going to kind of continue still using Facebook as my primary way of taking your questions. So the first one is going to be tackling what is a bearing. Then we're going to have a trigonometric function, which in my class we're going to be getting into in the next couple weeks. There you go. Looks like the chat is now populating. Awesome. So I'm just going to I'm not really going to do a great graph because we don't really cover graphing, like detailed graphing in my class. But I will kind of do a general graph kind of base, at least kind of get you when I used to teach this back in the day, how to graph a trigonometric function like that. But really also what I do in my class now, which is just identify the, kind of important characteristics. And then we're going to multiply a trinomial times a trinomial and do a binomial expansion, also reviewing the Pascals triangle, and then solving a quadratic equation. And I know I'm going to get some more questions coming in from you guys on the live chat, which I do see you guys that are definitely adding in some questions. And yes, I am a high school math teacher. I have been teaching since 2007 as a high school math teacher in the same high school in Jacksonville, Florida. So basically high school, went to college, got a degree, went to teaching, and I've basically been a math teacher ever since then. So kind of crazy. I don't really know anything different than really being a teacher or being inside of education. And so yeah, it's been pretty good so far. And man, do you do at least 3 equations since you don't do a live stream last time? Well, Caesar, I do appreciate that. One of the things I wish I could probably do some extra equations that, and we'll kind of see how the live stream goes. I mean, every live stream I always go a little bit farther on. I will say I'm a lot more tired than I usually am because I've been trying to wake up a little bit earlier so I can do actually a little bit more content ahead of time before my classes, before doing some school. And so actually this weekend I was pretty good. I woke up early both days, Saturday and Sunday, and got some, I did actually my recordings for my students in class, which you guys will be seeing on YouTube. That will be published here rather soon. And so yeah, I was making those recordings really early in the morning. So it was kind of cool. But yeah, I am extremely tired right now. And I was actually second guessing myself doing this live stream because I was like, man, I'm crazy. I'm so tired right now. I don't think I can go live. But can I? And I oop. Cookies truck. Can you please say and I oop? Sure, I guess so. Graphic trick function. I am definitely covering those, Jennifer, so don't worry about that. All right, guys, I see a lot of questions coming in there, and I do apologize. I know some people are joining the chat. Please, guys, actually, and a couple of these questions, actually, I want to let you guys know about this too, especially if you're coming back through the, for the replay. So I think the last 2 questions actually are from last week. People responded last week. So, I mean, obviously, I'm going to handle people that are responding to my Facebook post first. And then I go to the community chat, people that were actually active on YouTube that are responding there. And then I actually went back to like an old chat and be like, hey, did anybody like add a question that I didn't respond back to? And that's actually question number 4 and 5. These are actually like a week old, and hopefully they still want help and this helps them out. But I wanted to, help them out as best I can, because obviously I know like these questions that are coming in, I just don't have time to read them or go over them. And I do apologize. I know you guys are like, join the live stream. You didn't know, you forgot about it, whatever may be the case. But as far as like to go over or add additional problems, it just becomes really tough, especially when I have multiple questions coming in. So I'm going to try to do my best. I'll see if I can add in some additional questions. But for right now, I want to kind of tackle these first 5, and then we'll kind of see what we can do. So I see Musa, Jamar, Nestor, Kyle, Gravity, Emily. Very happy for you guys to join on, and the rest of you that are going to be coming onto the stream, let's go ahead and get started. I do say, Emily said, what class do you teach? I teach pre-calculus this year, but I have taught everything from algebra 1 through calculus, at least in the high school setting. Here's a lovely picture that my daughter drew. We were practicing doing some live stream prep earlier. And this was her lovely artwork. So, all right. One of the questions first came in is, what is a bearing? And this is actually something that we are covering now in my class in pre-calculus. We're covering over angles and standard form. We haven't got to a bearing because I've actually kind of pushed that into another chapter. But really just kind of main thing is bearing is just another angle. I'm not going off of any, Google search or anything. But, we have standard form, right? So standard form, you have an angle like that. Right? So really just in a bearing, it's commonly used obviously in navigation and in the real world, whereas standard form is kind of like more of this mathematical standard form. So really there's a couple ways that we can use bearings. The one is what we use is with our cardinal direction, northeast, southwest. That's a really bad east. There we go. All right. So one thing that we can do is when we're always talking about bearings, I think the important thing is the initial side is always due north. All right. That is different than our standard form. So standard form, the initial side is always from the positive side of due east. Whereas from a bearing, the standard form is always from due north. So there's a couple different ways I can draw, like I think in my class, we did like 30 degrees. All right. Now, how can we draw 30 degrees? Let me do this a little bit better. So here's 30 degrees in standard form. All right. So if I want to draw that exact same angle, but using bearings, here's how I could do it. I could say north, 60 degrees east, because you baked north, you're going 60 degrees east. Right? So if that's 60, obviously that is going to be 30. It's the same angle, right? I mean, you can see that obviously like the same measure of that side. And really we use bearings as far as like measuring like, a ship traveling at a bearing of like that angle, that terminal side, or, an airplane traveling on that side. Or a lot of times we just say a bearing of 60 degrees. And again, it's really kind of the same idea. The really only difference is you're going from due north rather than the positive form of the x-axis. So a bearing is, again, just another, it's not really a unit of measure. It's just a different way of measuring our angles. And we're going to be using from due north. So they're most commonly used for bearings or from navigation, usually with boats and airplanes is how we use them a lot. So that's why I kind of push them, that definition of them, into the problems where we're going to do a lot of word problems that deal with navigation. All right, question number 2 deals with basically graphing and describing everything. So here we have a sine function, and to graph the sine function, we need to understand the parts. So let's go through the parts of the sine function. B times x minus c plus d. All right. So one of the things when we teach the, graphing trigonometric functions, at least in my class, I tell students, how does A impact a graph? How does B? How does C? How does D? So A basically obviously is the stretch and the compression of the graph. It also reflects the graph about the x-axis, but it also tells us about the amplitude of the graph. And that's basically going to be how high and how low the graph goes without any vertical transformations. Or a better way to say it is really what is the half distance between the max and the min of the graph. However, when we have an amplitude, the definition of the amplitude is the absolute value of your A. So in this case, it is just 4. My B changes the period of the graph. Basically, the period, again, is how long it takes the graph to repeat itself. Yeah, I got a little super. I don't know why that showed up. That's so weird. Caesar, I appreciate you. You gave me a super chat last time. Do you watch Mr. Beast's new video? I did watch Mr. Beast's new video. Sorry, I had to break it up. I didn't want to do this. But I'm actually, I'm in a lot of new things. I actually had a new video. Sorry, I just had to break it up. About like trees and the 20 million trees and everything like that. And it was one of the things that I was kind of a part of as far as like the donation and before you guys even knew it as alive and everything like that. And I'm a part of that circle. That a lot of people were all talking about this and letting it know that it was going to go live, but I ended up not doing a math video from that. But I did see that. So Caesar, I do think that is an excellent cause, especially once I looked into a lot of the trees, and it's been really cool to kind of see how that has taken off and how much publicity that has grown. Or how much publicity that has grown. So I think it's really cool from that. And again, thank you so much for the super chat. I really do appreciate it. So the period for sine is going to be 2 pi divided by b. Well, in this case, my b is 3. So my period is 2 pi divided by 3. Our phase shift is basically going to be how far is the graph, shifting left or right. And therefore, you can see since you're adding pi thirds, that's going to be pi over 3 to the left. And then my vertical transformation is basically how far am I shifting my graph up and down. And you can see this is going to be down 2. All right. So to understand actually how to graph, and again, this has been a while. I haven't done this in, I don't teach this really in my class anymore. But the main thing is to understand what the initial form of the graph is. So let's go over the parent graph of sine. Okay. So we have 1, -1, and 2 pi. All right, so this is what we call the initial period of sine. It goes up to 1, goes down to -1, and it completes a whole cycle within 2 pi. All right, so it starts at 0 and it ends at 2 pi. Now, if we wanted to graph this, now again, typically what we do when we are graphing is we want to graph like 2 periods. And what we can do though is let's just focus on like 1 period for a second. So what we're going to do is, what I like to do is what we call the start. So what we're going to do is we're going to take everything inside of the function and we're going to set that equal to 0. So 3x plus pi over 3 equals 0. And then we're going to do the end. So obviously the initial period ends at 2 pi. So again, we're going to take everything and then set it equal to 2 pi. So that's going to be based on the transformations. Because again, remember, inside of the function shifts the graph left or right, right? So anything outside of the function, the 4 and the -2 shift the graph up or down. They are not impacting the graph left or right. So what I want to do is I want to determine where the new start and ends are of the graph. The other thing I want to do is also determine the x scale. And the x scale basically, if you like look at this graph here, obviously we have the endpoints like the beginning and the end. We have this kind of midway point, and then we also have the max and the min. Like those are kind of important points of the graph. So it's kind of helpful to kind of know like where those points occur. Now obviously this occurs at pi halves, and 3 pi halves. All right, so let's go ahead and the way to determine the x scale is basically going to be the period, whatever the period may be, over 4. All right, so let's go ahead and get this all set. So you divide by 3 here. And then we have x plus pi over 3 equals 0. So x equals negative pi over 3. The end, you're going to divide by 3 and then subtract. So divide by 3. So then we'll have, let's do this, pi over 3. Oh, I'm sorry, hold on. Yeah, so you have pi over 3 is equal to 2 pi over 3. So I'm sorry. Divide by 3 on the outside, you have x plus pi over 3 equals 2 pi over 3. All right, so if you subtract pi over 3, that means x is going to equal a positive pi over 3. Interesting. And then our x scale is going to be 2 pi over 3 divided by 4. This always got students, it's been a while since I've done this. This always got students messed up, was multiplying by the reciprocal, which becomes, that divides out. That becomes a pi over 6, which is the same thing as a 2 pi over, trying to think, pi over 6, which becomes a 2 pi 6 over 12. That's not going to really help with that. Pi over 6. I was trying to think of pi over 3. All right, so either way, let's just kind of forget the x scale. That's not going to be any, well, 2 pi over 12. I don't think that's going to help out. All right, so let's go ahead and get a rough sketch. So we have pi over 3, or negative pi over 3, is now the new start. Instead of at 0, 0, it's now at negative pi over 3. And then we have at 2, or at pi over 3. Okay? Now, there are a couple other things that are going on. Not only, that was just a shift left to right. In addition to this problem, which is like not a very basic problem, the graph also has an amplitude of 4. That means it goes up to 4 and down to negative 4. But the graph is also being shifted down to. So originally, without any vertical shift left or up or down, it went as high as 4 and as down as 4. But then once it gets shifted down to, now the graph only goes as high as 2 and as low as 6. So 1, 2, 3, 4, 5, 6. All right. So basically, this is going to be your midpoint here. So I'm just going to kind of, and actually we can kind of recognize that this is going to be negative pi over 6, and that's going to be pi over 6. So my graph is going to go, it got shifted down to, so then it's going to start down here. That's going to be my max. That's going to be my min. And there you go. There's a oh, no, that's wrong. What happened here? That's going to be your max. Oh, that crosses there. My bad. Disregard that. Okay. So it starts at down to. That's correct. That's going to be your max. That's going to cross. That's going to be down. There you go. And that's going to come up. Now the graph is bad, obviously, and I take full credit for it. It's been a while since I graph, and obviously I have this little pen here. But hopefully you can kind of see how to go ahead and do that. And, oh, geez, man, I know I'm running out of time, and I know you guys are bringing in questions, and I apologize, guys. I just don't have enough time to answer everybody's questions, but I do see your questions. I really do appreciate it. Please make sure, guys, I do plan on not being sick next weekend. So therefore, if you have questions or you want some problems for me to do, please make sure. I usually only have enough time, or I usually only collect like 3 to 4 questions that people describe in the comment section that I can actually use. So for those of you that are, getting those questions into me, I apologize. I just do not have time to go through those comments. For the rest of this live stream, I have 3 more questions to go through, which is going to take me to the time that I have. But please make sure you guys are following through on the community board, as well as on my Facebook channel or on my Facebook page. All right. So here I have a trinomial times a trinomial. So one thing, you could always do distributive property, But I think when doing distributive property with trinomials times trinomials, it just gets a little bit too confusing. So what I like to do is the box method. And the thing I like about the box method is it just organizes everything. So as long as you have everything in standard form, you can just label each term as a row and as a column. And then remember, like the product of any two numbers or polynomials or expressions is going to provide you with the area. So if we have a trinomial times a trinomial, basically all we're doing is we're multiplying these kind of sections to find the area of each box. And then when we combine them all together, that obviously gives you the area of the box together. So 2x squared times x squared is going to be a 2x to the fourth. X squared times 2x is going to be a 2x cubed. X squared times 1 is going to be an x squared. 2x squared times a negative 2x is a negative 4. X cubed, negative 2x times positive 2x is a negative 4. X squared. And a negative 2x times 1 is a negative 2x. 2x squared times 3 is a 6x squared. This becomes a positive 6x and a positive 3. Now, the best thing I like about the box method is, especially when you have things in standard form, the diagonals are like terms. So all I got to do is, instead of doing like the vertical method that sometimes you might have done or that you guys have been taught, we can basically take this top left corner, 2x to the fourth, and then now add up the columns. So this becomes a negative 2x cubed. This becomes a 2x squared plus a x squared. So that becomes a plus a 3x squared. And this is a 4x plus 3. So there you go. Whenever I have to multiply any polynomials, I like doing distributive property, basically with binomials, but anything like larger than binomials, I like to use the box method. And obviously that was the instruction from there. All right, so these are two questions that kind of came from last week's live stream that I didn't do because I was sick and I was tired and I just couldn't do it. But I'm going to try to satisfy them as well because I have some kind of questions. They wanted to kind of understand, like, how do we create Pascal's triangle and then how would we expand this? So I'm not going to simplify it, but I will expand it, at least for them. So first of all, whenever we have the expansion, we need to understand that, first of all, we couldn't multiply them out. And I have students that have done this over and over. Like, you can multiply 2x minus 1 by itself 5 times. But really, to multiply that, you can already see how much work this was. Like, just imagine, like, multiplying that out. It's going to be a lot of multiplying. And I had students that just did it on their quiz and their test. Or like, you know what, I'm just going to try it. And some of them got it right, but most of them got it wrong. So my advice to them was saying, all right, let's go through understanding the binomial expansion as well as the Pascal's triangle. So let's just create Pascal's triangle. And Pascal's triangle a lot of times starts, or to understand Pascal's triangle, it starts with this kind of triangle of ones. Now again, Pascal's triangle basically gives you these coefficients without like the 2 here. If we just had, for instance, if this was like x minus y to the 5th, Pascal's triangle is going to give you the coefficients of each and every term of the binomial expansion. Now, obviously, once we have any numbers as coefficients there, that's going to be used as a scalar. So this is really going to be any term raised to the 0 power. Any binomial raised to the first power is just 1 and 1. And then any term raised to the third power is going to be 1, 2, 1. So one thing that you can, let me see. Yeah. One thing that you can always remember is, I'm sorry, that's not to the third power. That's to the second power. That's to the first power. That's to the second power. That always, the second term always kind of tells you what that power would be as it would be expanded. Because I think when you're trying to get to like the 5th power, you're like, well, what is the row in the Pascal's triangle? So again, if you were to expand Pascal's triangle to, or a binomial to the third power, you would have these scalar coefficients of 1, 3, and 1, 3, 3, and 1. Now, how do we continue building Pascal's triangle? Well, again, if you kind of notice the pattern here, the 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. And then you can kind of continue that pattern all the way down. And again, this is going to be a binomial to the fourth power. And for this question, we wanted to know what is the scalars for a binomial to the fifth power, which again is going to be this row. But you can continue following the pattern of adding two terms to get to the next row. All right. Now, the main important thing is really understanding these binomial expansion. And this is something that I spent a whole lesson on. So I don't have time to go ahead and do that. But what I will say is the first term is always going to be to the power of your binomial expansion. The second term is going to be starting at 0. And then basically what we do is we take the first term going down in descending order and the second term going into ascending order. So it's going to be plus 2x to the fourth, negative 1 to the first, plus 2x cubed times negative 1 squared, plus 2x squared times negative 1 cubed, plus 2x to the first times negative 1 to the fourth, plus 2x to the 0 times negative 1 to the fifth. Now, it's important when you have this negative 1, this second term, because it's really 2x plus a negative 1 to the fifth power. But it's important that that's going to give you actually an alternative term. It's going to go positive, negative, okay? Now, the other thing that's important here is that we're not done. This is just the binomial expansion. Remember, these terms give us our coefficients. So that's going to be 1. That's going to be multiplied by 5. This term's going to be multiplied by 10. This term's going to be multiplied by 10. This term's going to be multiplied by 5. And this term's going to be multiplied by 1. So again, that's why those terms, each and every one of those terms is going to be multiplied by Pascal's triangle. And that's how we use that binomial theorem as well as Pascal's triangle for a binomial expansion. And again, this is just a very quick way to be able to get to that. You would need to go ahead and simplify from there. The last one, I'm not really sure if this is exactly what they sent over, but I mean, this is at least what they typed, so I'm just going to kind of work with this. But it is something that, I've noticed a lot of my students really have trouble with is when they have a quadratic, they've totally forgotten how to solve. Now, the nice thing about this quadratic equation is that there's only one x, right? And the x is squared. So we know we need to solve the x squared either by factoring or by using the square root method, using inverse operations, obviously, or the quadratic formula if it's non-factorable and you can't solve, or you can't use inverse operations. But since there's only one variable, I'm just going to use inverse operations, right? We only want to use factoring and quadratic formula when we have like more than one variable that we can't combine. But in this case, since there's only one x, I'm just going to use my inverse operations. So I'm going to subtract a 10. And my goal here is to isolate my x squared. So I get an 8. Now divide by 7. So I get an x squared equals 8 over 7. Now to undo the square root, I need to do plus or minus, to undo the squaring, I need to use plus or minus the square root. So therefore, that's going to be plus or minus the square root of 8 over 7, which again we can rewrite as plus or minus the square root of 8 over the square root of 7. Now, we know that the square root of 8 is 2.8284271. The square root of 7 is 2.6457513. But those are irrational numbers. I am just approximating them. So obviously, those numbers are going to continue going on. But we can simplify at least the square root of 8 to be 2 square root of 2 over square root of 7. Then, typically, at least right now in my class, we can rationalize the denominator here. And we get 2 square root of 14 over 7. So therefore, x equals plus or minus, that didn't go away, 2 square root of 14 over 7. All right, there goes, ladies and gentlemen. I do see a lot of you guys and that have added into the chat, and I feel so bad. Typically, I would be more than happy to do a couple extra questions. It's 9:30, and usually a lot of times I go to like 9:40, but I am exhausted from making some videos earlier today. But I will plan on going live again next week, guys. And again, I really do recommend that you send over your questions to me, guys, early, so therefore I can review them and then put them on my sheet, because I really do like going through the questions, like having them available, so therefore I can knock them out quickly. And then also, if I have more than like 5, I know I don't need to go as in depth. But if I only have 5, I'm going to go more in depth. Even though I see Kara, I see Gage, I see Chris, Arian, Akram, Random. I see you guys obviously putting in your questions and saying hi, and I appreciate it. I just don't have the time to kind of go through those questions. So I will plan on going live though next week for you guys. And I do apologize. I'm just so tired. So I love always picking up extra questions, especially at the end, for those of you that have been hanging out with me through this whole live stream. Tonight is just not the night. So, but either way, guys, I do appreciate it and look forward to connecting with you this week with some more uploads. Otherwise, you guys study hard, and I will see you on the next live stream. Cheers. Where's we go? There we go. That didn't work. We'll try it again.